Hi, class. This is Charity McKenzie, and this is the first section of statistics. It's called Statistical and Critical Thinking. It's section 1.1. And I don't really have anything to write out and show you for math problems. So I'm going to walk through the main idea of this section. And then there's other videos from the company that you're welcome to watch if you need more help. So the main idea is the process that's involved in creating a statistical problem or question. So the big idea is to prepare, to analyze, and then make a conclusion or conclude. Okay, so that's our key idea for today. So what is data? Well, most people know what data is. It's just a collection of observations, or they're like measurements of something, or genders, or responses from some kind of survey, typically online. Just some data. So we could go with COVID, we could go to the CDC website and we could collect data on what's going on, and we could make our own analysis of what is going on. This class should prepare you for making your own conclusion from data. That's the whole point of this class. So whatever job you're going into, whether it's the medical field, whether it's a teacher, whether it's social sciences, it doesn't really matter, or business. You have places in your job where you can collect data and then take that data and make some statistical analysis from it. Okay, so statistics is just analyzing. So you're going to plan. So we're in the planning phase or collecting of data phase right now. An experiment, you're going to get data, you're going to organize, you're going to summarize, you're going to present. That's the whole idea of statistics. Okay, so when we go to collect our data, a population is everyone in your sample. So if I'm doing a sample of all adults, it's every adult in the entire world. Or, you could say the adults in Sheridan, and then that's the adults in Sheridan. That's your population. Can I do a census very easy? That is a collection of every person in your population. No, it's hard. Even if I wanted to do a census of everyone that goes to school at Gillette and Sheridan, I don't think everyone's gonna answer my survey. So it's really hard to get what we call a census. Okay, and we hear about the census of the United States. That's collecting how many people live in the United States. Okay, so what do? We get a sample, and that's a sub-collection of that member. So if I said all the adults in Sheridan, a sample might be every other person in Sheridan, or a sample could be I randomly sampled every other neighborhood, and then in every other neighborhood, I randomly sampled every other home, something like that. Okay, so here's an example. In the journal article, residential carbon monoxide detector failure rates in the United States. So failure rates are those little, it's like a smoke detector, but it detects carbon monoxide. It was stated that there are 38 million carbon monoxide detectors installed in the United States. When 30 of them were randomly selected and tested, it was found 12 of them failed to provide an alarm in a hazardous carbon monoxide condition. Okay, so I already have the answer on here, but what is the population? What is the total of whatever I'm talking about? It's all detectors. So there are 38 million, everything. Okay, what is my sample? My sample is the 30 that I selected and I tested. And it's funny, you probably go, that's pretty easy, Charity. And I'm like, no. Sometimes it's hard to think through the population and the sample. On my final exam last semester, people really struggled with that idea. Okay, so you have quite a few questions in your homework that will make you kind of pick what's the population and what's the sample. I think I even added a couple extra. Okay, so when we're doing a statistical problem, we're going to prepare, we're going to analyze, and we're going to conclude. That's what we're going to do this whole semester. Okay, so the prepare, that's our context. What do the data represent? What's the goal of my study? What are the sources? How am I going to get my data? And how am I going to do sampling? How am I going to get those samples? We have a whole nother section on sampling methods because that's huge. If you do not set up your problem correctly, then all of your data is flawed. Okay, so when I see data in the world, or somebody telling me 48% of this or whatever they give me, right? The first thing I say is, where did they get their sample and how did they get their sample? So I think that's important, especially when I'm a cancer survivor. So when I was in like where you're doing the percents of like, if you do chemo, it'll give you this much percent of being alive, right? So that kind of stuff is like super serious. Like, where did they get their sample? And a lot of times we just take for granted that they did a good job. No, no samples are not good. I know that's mean of me, but they aren't. You have to get a good sample. So we'll do a lot more in detail on that, but we want it to be random, okay, of your population, always. That's your goal. There's different methods to get that random sample, but random sample, that's what we want. We don't want every person with the last name A because not everyone had a chance. It's not random, okay? All right, so then we analyze our data. Of course, we'll spend some time on this. So we're going to graph, we're going to explore the data, things like how do you find the middle of your data? That's your mean, median, mode that you've seen in other math classes. How do you see how spread out your data is? That's your range and your standard deviation. Are there missing data is in here too? That's more of misleading. And then it's like, did you select subjects that refuse to respond? So that's just more of your sampling. But all right, so we'll do a lot with that too, but that's the idea of analyzing. And you also will use a lot of technology in this class, and the biggest one will be StatCrunch. If you have a graphing calculator, it actually does everything StatCrunch does, but StatCrunch is pretty easy to get some of our calculations from. Some no, it's not, but you could use it for all. It is a button in MyMathLab that you will click and it'll open, and it's a calculator. You log in using your code through MyMathLab. There's always someone who it won't open, so check it now before we really, really need it. When you have to contact the company. It's a subscription, and sometimes the subscription is a little messed up. Okay, all right, last thing here. What are the pitfalls? So misleading, of course, we can form conclusions based on our analysis and make statements and really mislead people. Okay, so, oh man, misleading. We could keep going on, especially right now in the world. Sample data reported instead of measured. So misleading data, I think, mostly comes from this idea. You answer questions online on a survey, and that is so misleading, right? Because first of all, it's whoever wanted to answered. That's misleading. It's not random. It's not everybody in the population has a chance because it's just, well, I guess they do. But it's not good because you're picking to choose and answer that question. So when you collect data from people, it's better to measure it yourself than to have them state it for you in that survey. So if I get a survey of how tall everyone is, and I want to see if women are taller now than they were in the 1950s, when I have people state it and I don't measure it, lots more air in there. Because I'd love to say I'm 5'10", and I'm not. I'm just not. Used to think I was 5'9", but I'm not. I'm 5'8". I shrunk. So when you report data, there's error, right? Makes sense. Getting your sample, there's error. Analyzing your data, there's error. So that's why this class is for so many different subjects. You need in your topic that you're going to be in, studying in or a job at, you need to be able to analyze things yourself, not take somebody else's not take their word for it. Okay, loaded questions, huge. So in a survey, you could definitely load your questions to make it go the way you want it to be. The order of the questions, you get bored, right? So you answer the first 5 and they put 50 on there. So, order of questions can be very misleading. You can get no response from a lot of people. I know the census is that way. People didn't fill it out. So people had to go door to door and knock on their door and say, how many people live here? And then they're going to get someone like my dad, and he's going to say, I ain't telling you. It is what it is. So percentages, um, very easy to mislead with your percentages because people, I don't know, they just list what they think, or they calculate it wrong, or yeah, just be careful of the percentages, or they can be misleading. Okay, the last thing, and it is something we will say again and again. So I know this is probably the most weird idea for the day. So statistical significance. This is it statistically significant? Okay. It is achieved in a study if the likelihood of an event occurring is a chance 5% or less. I don't want you to focus on the 5% or less. Is it statistically significant? So for example, if I got 98 girls out of 100 births, that is very statistically significant because it's not a very likely, um, it's such an extreme outcome. It's not likely. That's significant. It's different from the norm. So when I do a test of something, if I get something statistically significant, I might be finding like a new cure for cancer. Look, this is significant from chemo or these other methods, this radiation that people are using. So I can maybe prove that this is different. It's different. Getting 52 births out of 100, well, yeah, 50-50 chance. That's way close to 50. That's not I'm not going to be able to say it. Statistically significant. Because like 52 out of 100, pretty close to 50%, right? It's not a reason to be like, whoa, there's way more girls in this world or in this city or wherever. Like something's in the water, everyone's having girls. Nope. It's probably your sample. It's just too close. 98 out of 100, very different from the norm. So we're going to talk a lot about statistically significant. Is it enough of a different from the norm for us to say, look at this? Okay, practical significance. Is it possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use? So there's a new medication. They swear if you take it, you're going to have a baby girl. They swear it. And it's 52 out of 100. I mean, yeah, it's showing you're having more girls, but is it really practically significant? Your decision, okay? Can it really be justified? All right, that's the main idea. The questions are a little tricky with trying to figure out that population versus the sample. The rest of this, I think you'll be good. A little bit wordy on the homework, but it won't take too long. All right, good luck on your first homework.